Hello, today is going to be a short video on how rainbows form. And we're going to get right into it here and start thinking about what you need to form a rainbow. Obviously, you need rain, okay? You need somebody to look at it, and then you need the sun to shine. So you need those three things. Somebody to look at it, you need the rain, and then you need the sun. So now what order do those three things need to be in? Well, you need to be in the middle is the key. You need to have the sun to your back. So I'm going to draw the sun over here. So there's the sun. Then I'll put you kind of, down below here. So there's your eyeball, like that. And then the rain's going to be falling in front of you. So let's say there's a cloud somewhere up here maybe, and then the raindrops are all falling in front of you. And I'm going to make a really big kind of exaggerated raindrop here, like that. Okay, that should be a round raindrop there. And now we kind of think about our last lesson when we talked about why the sky was blue, or go back to your astronomy lessons when you think about what color light comes from the sun. Well, what color light comes from the sun? White light, which has, again, all the colors of the rainbow in it. Okay, we hear this rainbow, all the colors of the rainbow. Okay, that's where we get it from. So white light comes from the sun. The white light is going to hit each and every raindrop. And as it goes into the raindrop, it changes its speed because the water is more dense, and it's going to slow down. And when it does that, the light bends. Now your fancy word for bending is refracting. So light is going to refract. And the key thing is that each color in the white light is going to refract at a slightly different angle. The red light is going to refract the least. So I'll put the red light kind of going up, should be going refracting a little bit at least. So the red light's going like that to the back of the raindrop, and then the violet light is refracting the most. So the violet light bends the most. It's kind of like that, let's say. And all the other colors of rainbow in between. I'm not going to draw all of them in there because it'd get awfully messy. So they all refract when they go into the raindrop in the front. When they hit the back of the raindrop, they're going to reflect. So they're going to bounce off of. So I'll draw my purple one off first, and my purple is going to reflect like this, let's say, and then my red one will reflect and come off down below. So you notice that they cross, so now the red's coming down below here. And then when they come out of the raindrop, they're going to refract again. So you see, like in this picture, they're going to refract again and go to my eyeball. So I'm going to have my red one going to my eye like that. The violet one, I'm going to have actually missing my eyeball. So it's going like over my head somewhere. Okay, and that's why we have red at the top of the rainbow. So you see pictures of rainbow like this. We have red at the top of the rainbow, then orange, yellow, green, blue, and violet. The reds at the top coming from the raindrops up here. Those other colors of the rainbow are coming from the raindrops lower in the sky. So if I had more raindrops down here, I'd be getting the different colors from them. That kind of makes sense. And I've got another little video that I can link to this one that you can file that'll explain that a little bit more. But kind of in simple terms, we're getting the red colors, the red, orange, yellow, from the raindrops near the top, and then the violets and the blues and stuff like that from the raindrops at the bottom. So your color order, again, I think you know. So you have, I just do it, let me do it in black so you don't confuse you. So our color order would be red, orange, yellow, green, blue, and violet. Kind of that Roy G. Biv idea. Used to have the indigo in there as Roy G. Biv, but that was taken out quite a few years ago because it's not a distinct color. So we have our Roy G. Biv there. So the key is, again, the white light refracts each color differently as it enters, reflects off the back, and then comes through. Okay, well, have you ever seen a double rainbow, or it's called a secondary rainbow? Probably a lot of you have. And how that forms is not completely different, still the same way, but you see kind of in the picture, here's the picture that we had before of the normal raindrop. The white light comes in up here, refracts, bounces off, and enters. For the secondary rainbow, or the double rainbow, it's going to use different raindrops. The light is going to come in at a different angle, coming from the bottom here, refract, reflect twice, and then refract out. So the key for a secondary rainbow is there is a double reflection inside the raindrop because of the angle it comes in at. Think about if you're trying to skip a flat stone on a lake. Okay, if you get the right angle, you can skip it multiple times. That's what happens for this light that's going in. It got just the right angle, so it kind of skips or reflects off the back of the raindrop twice and then comes out. When it does that, you're going to notice a couple things. First thing is the colors are reversed. So in the normal raindrop, the primary rainbow, you have red on the top, so red, orange, yellow, green, blue, violet. On the secondary rainbow, the red is on the bottom, so going up essentially, or outwards, red, orange, yellow, green, blue, violet. And again, the picture shows you kind of the normal primary one here, and then the secondary one here. And then they're fainter. You see the secondary rainbow is fainter because more of the light is used up in this double reflection. You also have this Alexander's dark band, which is kind of interesting, and they'll talk about that in another video. Like I said, I've linked to this if you want to watch it in my playlist too. Here's a picture of us on our Colorado trip, the 2016-2017 Colorado trip, and we had this beautiful double rainbow. You see, again, the colors of the primary rainbow, red, orange, yellow, green, blue, violet, with the kind of brighter sky here, Alexander's dark band in between, and then the red, orange, yellow, green, blue, violet going kind of the opposite way with the darkness there. So really pretty and neat picture. I'm glad we got to have, see a really nice picture after a week of rain going there. One thing also to notice, and we kind of referred to this a little bit in the blue sky lesson, is that when you look at this, the violet really doesn't show up very well. And again, that's not necessarily the case of the light, it's a case of our sensitivity, our eyes. We see, again, the blue much better than we see the violet, so it's hard to see that violet in here. Kind of the red and orange, which our eyes see much better, are a little bit more overpowering that we see in there. That's kind of another double rainbow picture. I think kind of last, just a few kind of characteristics about rainbows that you might have been wondering about. And kind of first thing is, why is it an arc, or really it's a circle? If you go up like on a mountain, or if you use a hose, you can make your own kind of circular rainbow. And the key is, again, is this refraction angle that I talked about. And here is a kind of a neat picture that shows that each color refracts at a slightly different angle. Red is 42 degrees, as you can see here. So if you would take your eyeballs here and you were looking, it's going to be this circular shape, go kind of 360 degrees around, but go 42 degrees out, and you will get an arc. And then, like I said, each color is a little bit differently. So then you have that old myth or legend or whatever that if you catch a leprechaun, maybe he can take you to his pot of gold, or there's a pot of gold at the end of the rainbow. Kind of that legend there. Can you ever get to the end of a rainbow? No. You can never get to the end of the rainbow. You always have to be in the middle of your rainbow. So it's kind of another one of those characteristics. If you notice, you are always in the center of your rainbow. And again, the reasoning is because of this angle that they refract, kind of going in all directions out at 42 degrees in this case. It has to be that color. So you can't move to one side or the other without that rainbow moving with you, because otherwise it wouldn't be the same angle. So no, unfortunately, you're not going to get the pot of gold when you go to the end of the rainbow. But maybe you can take solace in that, at least, in that the rainbow that you're seeing is your own personal private rainbow. Okay, everybody sees their own rainbow. You're in the center of your rainbow, your friend's in the center of their rainbow, because, like I said, you're using kind of different raindrops. Millions of raindrops make up your rainbow, and you're the only one seeing that exact one, and you are in the center of that rainbow. So that's really the lesson. Kind of if I go back real quick and just kind of go through the steps real quick so you have that. Again, white light comes from the sun, which has all colors of rainbow, and it's going to enter the water droplet. And each wavelength is going to refract at a slightly different angle. Some of that light then is going to reflect off the back of the raindrop, and then it's going to refract to your eye as it comes out to make the rainbow that you see. And that was it for rainbows.